You know, for decades, we've all dreamed of building a new home on Mars. But what does it actually take to turn that sci-fi vision into a scientific reality? Well, it means we have to confront some of the biggest challenges humanity has ever faced. So in this explainer, we're going to break down the practical hurdles we absolutely must clear to survive on the Red Planet.
I mean, the dream is incredible, isn't it? You can just picture it. Domes and habitats scattered across that alien landscape, a little beacon of human ingenuity millions and millions of miles from home. This vision has been fueling space exploration for generations. But before we can even think about building this, we have to figure out how to survive the planet itself.
And wow, this slide right here, it just lays out the massive gap between our two worlds. First off, the atmospheric pressure on Mars is less than 1% of Earth's. It's so thin that without a suit, your blood would literally boil. The air? It's pretty much all unbreathable carbon dioxide. And the average temperature is a bone-chilling minus 80 degrees Fahrenheit. It's simple, really. Our bodies were built for Earth, not for Mars.
Okay, so here's our game plan for this explainer. We've just had our Martian reality check. Next, we're going to dive into the 5 specific hazards to the human body. Then, we'll go on the hunt for the planet's most critical resource, water. After that, we'll explore the tech we need to build a new world, and finally, we'll ask the ultimate question: are we truly ready for this?
Okay, so let's dive right into our first big hurdle, surviving the hazards of just getting to Mars and, living there. A trip to the Red Planet isn't just some long road trip. It's a full-on assault on the human body, in ways we're only just beginning to fully grasp.
So NASA actually breaks down these dangers into 5 main hazards. You've got space radiation, which we'll get to in a sec, but it's also the intense psychological stress of being isolated in a tiny can with the same few people for years. There's the logistical nightmare of being so far from home, the weird ways altered gravity messes with your bones and even your eyesight, and of course, the constant stress of living inside a sealed, hostile box. And look, every single one of these is a huge problem to solve.
And while they're all serious threats, let's zoom in on one of the trickiest ones: space radiation. Here on Earth, we're protected by our planet's magnetic field and thick atmosphere. It's like a giant natural force field. But in deep space, astronauts are hit with a constant barrage of high-energy particles from all over the galaxy, with almost nothing to stop them.
And if you want to put a number on that risk, well, it's pretty scary. A 1,000-day Mars mission could increase an astronaut's lifetime risk of dying from cancer by a staggering 33%. Now, we can shield against some solar flares, but protecting against those super high-energy galactic cosmic rays, that is a much, much harder problem to solve.
Then there's just the sheer distance. A message you send from Mars can take up to 22 minutes just to get to Earth, one way. So imagine there's a medical emergency or a critical system fails. You can't just pick up the phone and call Mission Control for help. Nope. The crew has to be totally self-sufficient. They have to be their own doctors, their own engineers, their own problem solvers for everything.
So let's say we figure out how to keep astronauts safe from space itself. How do we keep them alive on the planet? Well, that brings us to our next great challenge: the hunt for water. We know Mars actually has a ton of it, but like pretty much everything else on the Red Planet, there's a catch.
I mean, we see the evidence all over the place. We found dried-up riverbeds, ancient lake deltas, all carved right into the surface. So if Mars was once this wet and maybe even warmer world, what happened? Where did all that water disappear to?
Well, it turns out the answer is down. A huge amount of that water didn't just escape into space. Instead, it soaked deep, deep into the Martian crust, where it's been locked away inside minerals for billions of years.
And when we say deep, we mean deep. Some estimates put these water reservoirs as far down as 20 kilometers, which is about 13 miles. To put that into perspective, the deepest hole humanity has ever managed to drill on our own planet is only about 12 kilometers deep. This is an engineering challenge on a completely colossal scale.
And this gets us to the real puzzle, right? The water is there. It's either buried miles underground or frozen solid at the poles. But where we need it is somewhere that's easy to get to, right near where we want to build our base. It's this massive logistical mismatch. The resources are in one place, and the people who need them are in another.
Okay, so with all these massive challenges, that leads us right to our next big topic: technology. We can't solve Martian problems with just Earth-based solutions. We have to learn how to live off the land. We have to use innovation to turn the Martian environment from a huge liability into a powerful asset.
And there's actually a really cool term for this idea: in situ resource utilization, or ISRU for short.
It's this game-changing concept of using what's already on Mars to survive, making air from the atmosphere, fuel from the soil, water from the ice. And listen, this isn't just a nice-to-have. It is absolutely essential.
And hey, this isn't just sci-fi theory, this is happening right now. On board the Perseverance rover, there's an experiment called MOXIE, and it has already successfully pulled carbon dioxide right out of the thin Martian air and converted it into pure, breathable oxygen. It's a tiny test, for sure, but it's a massive proof that this whole idea can actually work.
And the potential for this stuff is it's huge. Imagine using Martian soil, what they call regolith, as the raw material for giant 3D printers to create bricks, tools, maybe even entire habitats. And that very same soil, when you pile it up thick on top of a habitat, provides fantastic shielding from space radiation. You're knocking out two birds with one Martian stone.
I mean, just look at the difference here. On the left, you've got a rover being put together in a perfectly sterile, pristine, clean room. On the right, that same incredible machine is caked in abrasive dust in a freezing alien world. And remember that 22-minute communication delay? It means this tech simply cannot afford to break. It has to be tough, it has to be autonomous, and ideally, it has to be able to fix itself.
And looking even further into the future, the same kinds of technology we use to find water could also help us answer one of the biggest questions in the universe. There's this concept for a device called the Agnostic Life Finder that could analyze Martian ice, not just for drinking water, but for the complex molecules that are the building blocks of life. The very tech that keeps us alive there might be the thing that tells us if anything else ever was.
So what we have is a planet that's hostile to our bodies and technology that's pushed to its absolute limit. This brings us back to our final, critical question. After you balance all the risks, the costs, and the rewards, are we actually ready for Mars?
Well, the people who study this stuff for a living are pretty clear on what has to happen. First, we need a huge paradigm shift. The crew and their vehicles must be completely autonomous. Second, we have to develop faster ships to cut down that travel time spent soaking in deep space radiation. And of course, we have to master the art of living off the land. That ISRU thing we talked about, it's not optional. It's the only way this whole thing works.
And look, if you're still not convinced that we need to live off the land, just think about this number, $2 million. That's the estimated cost to ship a single brick from Earth to Mars. When your building materials cost that much, you don't really have a choice. You learn to build with what's already there.
So, I want to leave you with this final thought. Between protecting our fragile human bodies and inventing brand new technology for an alien world, what's the one problem we have to solve first? What's the one nut we have to crack to make a Martian outpost a reality? Is it the radiation? Is it finding the water? Is it making our tech fully autonomous? Whichever it is, solving that one thing is the key that unlocks humanity's future on Mars.